In lesson 8.1, we learned about simple and compound interest. Now, another type of investment where you can earn some money is called an ordinary annuity, which is a sequence of equal payments made at the end of equally spaced intervals of time. There are other types of annuities where you might make the payment at the beginning instead of the end, but for our purposes, all of our calculations will be at the end of the period of time. Okay. This means that the money in an annuity still gains interest on top of interest, just like a compound interest investment. However, there is no set principal amount since we keep adding to the investment into the account over time. So in this first example, Bob deposits $1,000 a year at the end of every year for 5 years. So how you know when you're reading a problem that you have an annuity is these keywords right here. Okay, the end of every year. So that means he's not depositing $1,000 once, he's depositing it $1,000 and then a year later another thousand and then a year later another thousand, so on and so forth. If the account pays interest at a rate of 9% compounded annually, what is his accumulated amount at the end of 5 years? So we're trying to figure out how much the total investment worth will be. Okay, I just need to make a couple of corrections to this handout, sorry. The first correction I'll ask you to make is just to indicate that on the left of this time diagram is the present time, which is year 0. And over here, this is not the present, this is future. Okay, 5 years into the future. So the first way we're going to learn about how to solve annuity problems is to draw a time diagram. Now, what I'm going to do is imagine that you have deposited, or this is Bob, at the end of the 5th year he deposits $1,000. That $1,000 doesn't gain any interest because now this is the end of the investment term. So that $1,000 just remains as $1,000. Okay. Now, he invests $1,000 at the end of the 4th year. So that means that you've had 1 year for that $1,000 to gain interest. So A4 at the end of the 4th year is going to be $1,000 times 1 plus 0.09 to the power of 1. This is we're using the compound interest formula, 1 plus I to the exponent n. Okay, since we have our interest being compounded annually. Okay, so I'm going to keep this pattern going. So at the end of the 3rd year, he invests $1,000. So that $1,000 has had 2 years to gain interest. Okay. At the end of the 2nd year, he invests $1,000. That $1,000 has had 1, 2, 3 years to gain interest. So 1,000, 1.09 to the power of 3. And finally, at the end of 1 year, that $1,000 has had 1, 2, 3, 4 years to gain interest. So 1,000, 1.09 to the exponent 4. Now I'm going to write all of these terms out in a row, and hopefully you'll be able to see a pattern forming. So A total is equal to A1 plus A2 plus A3 plus A4 plus A5. I'm just going to write it in backwards order. So A5, A4, A3, A2, A1. So 1,000 plus 1,000 times 1.09 plus 1,000, 1.09 squared plus 1,000, 1.09 cubed plus 1,000, 1.09 to the exponent 4. Okay. If you look at these amounts at the end of each year, you should notice that they represent a geometric sequence because we keep multiplying by 1.09. So since we have a geometric sequence for the separate terms, in order to add them together, we would use the sum of the geometric terms, this geometric series formula, to find the answer. So move on to the second video and I'll show you how that's done.